Assalamu alaikum warahmatullahi wabarakatuh. So what we want to do today is to send commands from one computer, which we will call from now on the server, to another computer, which we will call the client. We will use Python as a programming language because the implementation is simple enough that we can focus our attention on the process itself, not the connection, which means we do not have to worry about all these settings of the network. We just have to write what our program does. Okay, so before we begin, let's learn what's socket programming. Okay, so socket programming in Python. So socket programming is a way of connecting two nodes on a network to communicate with each other. One socket, which is a node, basically listens on a particular port at an IP, while the other socket reaches out to form a connection. The server is the listener socket, and the client he reaches out to the server. Okay, a simple implementation is import socket and s, which is the socket object which we will create, equals socket.socket parentheses and socket af init and socket sockstream, which basically means that we will create RB version 4, that's AF init, and sockstream means that we will be using the TCP protocol. For example, if we want to use the UDP, user datagram protocol, we will change socket.sockstream to socket.sock underscore dgram. Okay. So at first we will implement a simple client server program, which is basically a chat. So the server has a bind method which binds to a specific IP and a port so that it can listen on incoming requests on that IP and port. The server also has a listen method which puts the server into listen mode. This is basically for waiting for multiple connections, okay? And at last, the server has an accept and a close method. The accept method initiates the connection, and the close method terminates it. Okay. For example, this is the server side of a client-server chat program. First, we import the socket module. Then we create an object of the socket. Of course, we did not specify the parameters because if we do not, it will just load it as default, which is the socket AF init, which is RB version 4, and sockstream, which is TCP protocol. Okay, so we need to get the host IP address, which is our computer, because we will running both the server and the client on our local machine. There is a function called getHostName, which returns the name of the local host. Of course, we can also change this to be, for example, 127.0.0.1, which is a local loopback address for any computer. Okay. And the port number, which shows any number between 0 and 10,000, between 2 to the power of 10 and 10,000. So we do not have any conflictions. The first 2 to the power of 10 IPs are already used by multiple services on your PC. Okay, so next we bind the host and the port together to the server. We pass this parameter as a tuple. The tuple consists of two values. The first value is the host, and the second value is the port, and these are the parentheses of the function. Okay, so we list the number of maximum connection for the server as 5, s.listen. Okay, next we accept the connection by placing the output of this method into two variables, C and A. C is basically a connection, a connection object which we will use from now on instead of the socket. And A is a tuple consisting of the port IP and the port number, of the socket IP and socket port number. Okay. If the server accepts the connection, we want to print connection from and the IP number, which is the first element in the tuple. Next, an infinity loop while true. we set a variable, we call it x to receive, and we set its buffer size to 2048. Next, we print what the client has to say. With the print method, we pass it two parameters: the client and what it will receive from the client, decoded as a UTF-8 bytes. Okay, and next we send what the server has to say by using the input method and the send method. The send is the bigger method on the outside, then the input method, input, then this is what comes out to the server side, and it encodes it in UTF-8 bytes. At last, we close the connection. Of course, we will not reach this connection, this line, because it's an infinity loop. We could change the implementation to, for example, send a specific character to quit the connection. Okay, now to the client side. The client, the server that cannot work alone. It's a networking environment. So the client has a connect method which binds the particular client to the host IBM port. It also has a close method for closing the socket after the session has ended. Okay, so in port socket, we know that what that does: initiate an object of the socket, set the host to the local IP address. Of course, we're working on our local machine for training purposes. We set the same port that we set at the server. Okay. Next, we initiate the connection by using the connect method, which is we pass it two parameters in a tuple also, which is basically one big parameter. Yes, the tuple is one big parameter. It consists of the host and the port. We also make an infinity loop. We input what the client has to say, then we send it as UTF-8 bytes to the server, and we receive what the server has to say using the receive method, and of course we set the buffer size to the same size, which is 2048, and we print what the server has to say by using the print method. The first parameter is a string server colon and space, and the second parameter is the received bytes, of course decoded to be out on the screen. Then we close the socket. Notice that the server close method used with the connection c.close, and the client close method is used with the socket s.close. Of course, this is not obvious now, but in later examples, where will we have multiple clients connecting to the same server, it makes more sense to close that specific connection, not the whole socket on the server side, and closing the socket on the client side. Okay, so this previous part was an example of how we can make a simple chat program. Now, what we want to really do is to send commands via socket. Now, basically, text is we can interpret text as commands. Yes, so if we can send text, then we can send commands. So yes, that's basically what I said. Okay, first we'll have to learn about two modules before we can make this program. Before we can make a program to send commands via socket. The first module is the sub-process module. What this module allows us to do is to spawn new processes, connect to their input-output error pipes, and obtain the return codes. What does that mean? It means basically that we will create a sub-process on the client machine using commands sent from the server. Okay. The recommended approach of invoking sub-process is to use a run function. The run function is like a higher implementation. It's not for all use cases. It's more for simple cases. For advanced use cases, we will use the bobbin interface, which we will use here. Okay, so the second thing we want to learn about is the subprocess.py. The subprocess.py is a special value that can be used as the stdin out or standard error or argument to a bobbin interface. and it indicates that a pipe to the standard stream should be opened. The stream on the local machine, on the client machine. So it basically connects the sub process which is opened and brings its inputs and outputs and errors to this object of the sub process. Okay, std out is the output, as we said. Std error is the error output, and stdin is the writable strip object return. The second module is OS, operating system. What this module does is it provides a portable way of using operating system dependent functionality. For example, if we want to get the current working directory of the PC that we are running on, we will use the getCwd method, which basically returns a string representing the current working directory. The second function is os.chdr, which basically changes that current working directory to a path specified in the parentheses. Now let's get into the actual code. Okay, so as always, we start with the server side. At first, we import the socket module and the system module. The system module, we only import it so we can perform an exit function in case of a specified word is said, which in this program is a quit. Okay, so I will start the program from the bottom up. Okay, we will get to the main method. Okay, here is the main method. So our code only runs the main method. Here is the definition for the main method. It has 3 methods implemented in it: a method called create socket, bind socket, and socket accept. Okay, we will learn what each of these do up above. Okay, so at first we create a socket. So ignore the try except for now. At first we define 3 global variables called host, port, and s. We set the host to the socket get host name, and as we said, we can set it to the local loop back address. We choose a port, which will case is 4 nines in a row, and we initiate the socket object, which we said can use the default parameters. The try except is basically for when we cannot create that socket for any reason. For example, if there is already a socket with that port opened, it will show the socket creation error message and show that exception. The message is the exception and it will show it. Convert it to a string, then show it. Okay, the second method in the main was bind socket. Okay, it uses the same 3 variables in the create socket, which is the global host and the global port and the global s. It prints a message said it's binding the port and the plus string port, because port is a number, as we have seen. It binds the port IP and the IP and the port number. Here I have implemented an empty single quotes for the IP, because in this example, if we want to send commands to multiple clients and they run their client program, we do not have to set a specific IP. Just any IP, many computers can connect to it. So I did not specify a specific IP for the bind method. I only binded it with the port. So for example, if another client with IP, let's say X, tries to connect to the port number, which is 4 nines in a row, it will connect. If another computer has IP Y and has the same program and of course the same port number, it will also connect. So I did not specify. Of course, we are running on a local machine, so that this does not matter now, but in future it does. Also, we set the maximum queue of incoming connections to 5. Also, this is in a try except block. If this did not work for any reason, it will show the exception as a string and socket binding error, and try to bind the socket again and show the word retry. Okay, so the third function in the main method or the third method inside of the main is socket accept. Socket accept the same as the previous program. It returns the connection as a connection object and the address as a tuple consisting of two elements or two or more. I don't know. I cannot specifically say for the moment. Okay, and it prints the connection has been established plus the IP number and shows the IP number, the port and shows the port number. Of course, we have to convert it to a string because the port is a number. Then it calls a function called send commands and passes it to the object con, which is the connection. Then at the end it closes the connection. So now we have to go to the send commands function. Okay. Send commands. It takes also the parameter name is con. This is the variable name and this is the parameter name. I just happen to write them as the same. I can change them if I want. Okay, so it contains an infinity loop. It creates a variable called cmd and equals to input from the user, which is the server side in this case. It checks if this line that it took from the server is quit, then it will close the connection, close the socket, and exit the system. And this is the only reason we imported the system module. Yes? Okay. Now, if the user sends a command bigger than 0 in length, this is the length method, and the string, which is to encode the CMD as bytes. If it sends a command bigger than 0, which basically ignores the enter on an empty line. Yes, the new line, when you press enter in the CMD, it will not do anything. So then it sends the input command encoded, of course, in UTF-8 bytes to the client side. Then it receives the client response in a variable called client response. It converts the received words in using a 10,024 buffer, of course, encoded as UTF-8 bytes. Then it prints the client response without the need for a new line, as it specifies the end. Okay, so this is the end of our server-side program. Now let's go to the client side. Okay, now this is where all the fun happens. We have 3 modules here. Of course, the socket module, which is, what we'll need to use even connection over the internet, and the OS module and the subprocess module, which we talked about previously. Okay, so at first we create the socket object, we set the host and the port, we connect. Okay, an infinity loop. We receive the data using the receive method using a 10,024 buffer size. Now, if the data, the first 2 characters of it, this is the end, the beginning is not specified and the end is specified, but it does not include the second character, so only 0 and 1 decoded as UTF-8 bytes. If this decoded as UTF-8 bytes, if this is CD, then it will change the directory using the change directory method in the OS module. Of course, it will take from the third character, which is after the CD space, decoded as UTF-8 bytes, of course, and change directory to that path. That is the path that we want to go to, which is from the after the space to the end, decoded as UTF-8 bytes. Okay. We check if the length if data is bigger than 0, then we create a variable called cmd, and we set it to the subprocess.bobbin. Now, this is the bobbin interface we talked about previously. Of course, it will take all the data which is received from the server, decoded as UTF-8 bytes. This is the first parameter in the bobbin. Then it will set the standard output and the started error and the started input to the subprocess.pipe, which basically links the sub process with the command, the sub process inputs and outputs and error with the command. Then we create a variable called output byte equals to the cmd std out read and the cmd std error read, which is basically the output and the error combined into one string, and UTF-8 bytes to be specific, and put into one variable. The read method returns the string of the output, and the read method returns the string of the error, of course, here. Yeah. Also, we convert it to a string using the string method. Of course, it's encoded as UTF-8 bytes, so we pass that also. We get the current working directory, which is the directory we were working on in the client. This is the client program, remember. And plus this arrow, this symbol arrow and space. Now, what this basically does is return the current working directory. For example, here in my computer, if I open the command line, I have C users Hussein. Yeah, it's Hassan, but it's short, yes. Okay. If this was the client, the server can have any other name than that. Okay, it does not have to have the same name. So if the server wants to send commands, it has to know what directory it's working in. So we have to send the current working directory of the client. Okay. And another example where this is useful, if we, for example, send a command from the server to change the directory. If we do not get the current working directory in our server screen, we will not know that the command even took place, that it initiated or not. Okay. Then we send both the output string and the current working directory, of course, encoded into UTF-8 bytes. Then we print the output string on the client side. Of course, we also print it on the server side because here we have print client response. Okay. Now let's see it in the real world. To the left, we have the server program for the chat, and to the right, the client. Of course, we have to run the server first, so we write Python server.py server chat. Then we run the client. As you can see, it printed connection from and the IP address of the local machine. We can now send any text we would like. For example, hi. Now it's the server turn to reply. Hello. This is the first program we saw, which was the chat. Now we'll switch to the commands, which is our main program. So as previously, we have the server program to the left side and the client to the right. First we run the server, then we run the client. As we can see, it printed the message that the connection has been established, and it printed the IP and the port. Now we can send a command, for example, echo hi, which simply prints the word after hi, the word after echo. Echo hey, echo. For example, we can change the directory cd which goes back. If we press the command dir, it will show us that we really went back. Okay, so and that's it, and I look forward to seeing you in future videos.